Okay, so for this question, I am seeing nothing about means or standard deviation. So that lets me know this is about proportions. So I'm doing a test for proportions, and the student did correctly set up the null and alternative hypotheses, because we're trying to test the claim that is significantly more, that a true negative on the test is truly more than 0.32. So since this is about proportions, I probably should figure out the sample test statistic. And if you remember back last week when we were dealing with confidence intervals, we know the point estimate is that p hat number here. Let me try to get my board working here. Yeah, here we go. So p hat from this sample is going to be the 85 out of 216. And if we calculate that, I would think it'd be organized here, and I can't find my stupid calculator here. So 85 divided by 216, 85 divided by 216 is 0.394, I guess I'll go with. That's about equal to 0.394. So just looking quickly, that point estimate is higher than 0.32. Looks like our right-tailed test is appropriate. So let's run the test statistic now. To do this by hand, what you got to remember is we're going to do a z-score, because we want one prop z-test or one proportion z-test. We need a z-score as my test statistic. So my sample test, my point estimate is the point, my sample proportion is 0.394. I'm trying to test it against the hypothesized center of 0.32. And then since we are hypothesizing that the center is 0.32, that's what we're going to base our standard deviation on. And that's the P times Q, so 1 minus 0.32 over the sample size. What is there, 216? So that becomes 0.32 times 0.68 if I'm doing my arithmetic right. And I can just type that right into my calculator, and don't forget the square root, of course. I can type that right in my calculator as 0.32 times 0.68 divided by 216. Get that answer. So 0.32 times 0.68 divided by 216. I'm getting 0.001, some small decimals, right? 0.001. 0.007. I won't write down the rest of the decimals. I'm just going to let my calculator carry that. Then I need to take the square root of that. So I'm assuming you know how to do that. So I got a standard deviation of, for the denominator, of 0.0317. The secret of these proportions when you calculate them by hand is don't round too soon. I might be writing down that decimal, but I'm going to let my calculator carry the full thing. Now I'm going to subtract these two, and I think that becomes 0.074. So I'm going to do 0.074 divided by my last answer, that 0.0317 number. So I'm getting a z-score, a test statistic of 2.33. All right, now if I want to find the p-value, what I'm looking for is I'm looking for the probability of getting a z-score of 2.33 or better. So if I go to my table, go to my normal curve table, and I'm looking at 2.33. So let's see here. I think I can use a spotlight here. Nope, but I want the spotlight, not the pen. There we go. There we go. So 2.3, and I'm going to go over to the 0.3 column. So 2.33. I'm seeing 0.9901, and I got to remember that's the area to the left, and I want that area to the right because this is a two-tailed test. So let me do this. Let me grab that number so I don't have to remember it. Isn't it that number? 2.33, yeah. And I'm going to come back to my paint document and paste that in. So that is, whoops, I'm going to go to text, get a text. So that is, didn't work. 0. What was it? It was, oh, no, I can't see my stupid, this it, there we go. 0.9901. So 0.9901. So that's that area to the left, and I need to find the area to the right. So 1 minus that value, 1 minus 0.9901, it will be what the p-value is. So 1 minus 0.9901. So I'm getting 0.0099. I guess I could have done that in my head. 0.0099. So that's my p-value. That goes right here. That's how you would answer that. Now, that's a lot of work. We've got HO, HA set up. We know X, we know N. You know, that applet, that Ross-Chance applet works really slick with this. Make sure you select one proportion. We had, now you would think I could remember what I wrote. Here, where is it? We know we had, come on, slide over there so I can see it. We had 216 in our sample. We had 85 successes. And there's our p-hat. And I'm going to do a tested statistic, test of significance. I'm going to change it to 0.32 and greater than 0.22 or 32. I'm going to get calculate, and there's my 2.32. They're getting 2.32 because the calculator didn't have to round, whereas I did. And notice that p-value is a lot less than what I have. Oh, you know why it's a lot less? Because I went 2.33. I guess it really isn't that much less. So I'm pretty sure that WebAssign would take that, though I am a little concerned. That is a little bit different, isn't it? Well, it's not that different. It's 4 10,000ths difference. Usually WebAssign's not that close. That means to do this by hand, this is a whole lot less than 5%. What is the level of significance? Yeah, 5%. So either whether I use that p-value or I use this p-value, I'm going to reject HO. Okay, very small. What did somebody tell me last night on eTutoring? They said a low it rhymed. It was like a low p-value, no HO, go, or something like that. It reminded me of that Hall & Oates song. Something like that. But anyway, small p-values mean it's statistically significant. I mean, there is a difference. We're far enough away from that center to say something more than random chance going on. It's unusual. So hopefully that helps you do this kind of question, and then do some other significance tests with proportions. Long enough video, I'll upload it.